Hi all. We are going to talk today about Module 1.3 in Algebra 2. This is all about graph transformations, and we're going to be talking about how do graphs change. Our goals for today are to be able to transform or move a graph. We want to be able to write a rule that describes the transformation, and we also want to be able to describe a transformation from its equation. I can transform a graph in a bunch of different ways. I can move it left and right, I can move it up and down, I can flip it over the axis, and I can stretch or shrink it. I can do one of those things, I can do all of those things, or some variation in order to transform a graph. And we're going to talk about how to do those different things, both looking at a graph and looking at an equation. So looking at this graph, I'm going to go from red to blue. That's going to be our rule. So if I'm looking at the red one, I can see that this is a parabola, and it looks like it is probably the parent graph of x squared. I have moved it up 2 in order to get that blue one. Now, when I am moving up or down, I am adding or subtracting outside of the exponent or parentheses. So I'm going to write a rule for my new function that's going to be x squared plus 2. I moved my graph up 2, so I'm going to write my rule as x squared plus 2. That is the transformation of the parent graph, which is simply x squared. Now looking at this next one, again, I'm going red to blue. I clearly have an absolute value graph. So I've got an f of x equals, and this looks like it is the absolute value of x minus 4, would be the original red graph. Now I have moved that to the left. How many? I've moved it 2, 4, 6, 8 units to the left. So when I'm writing my rule for my transformed equation, notice I'm always starting with g of x. If my original is f of x, I can't call my second equation f of x. F of x is the name of that. That'd be like calling both of my kids George. Doesn't really make sense, right? Maybe one of them is George and one of them is Bob. They should have different names because they're different people. The same is true of functions. So if my first function is named f, you can call him Frank, then my second function needs to have a different name, so I'm going to call him G for George, all right? I'm going to take that original function, and this time, because I'm moving left, I am going to add 8 inside the brackets, which gives me an absolute value of x plus 4. Because I moved it left 8, I'm adding 8 inside the brackets. So moving left and right is always adding or subtracting inside brackets, parentheses, square root, whatever you might be doing, okay? Let me go back up and down. So moving it up or down is always adding or subtracting outside, either the brackets or the parentheses or the square root or whatever. So we have 2 different ways we can move it. We can move it up and down, which is adding outside. We can move it left and right, which is adding or subtracting inside. The one thing to remember about left and right is that they're opposites. So left means that you are adding, and right means that you are subtracting. It's kind of the opposite of what you think it would be. And that's simply because it's in the brackets with the x, and it's always x minus whatever number. So you're taking the opposite, okay? We can also describe a transformation. So here I'm given a parent graph, a Frank graph, if you will, of x squared. And I have changed that into the graph of x squared plus 4. I'm adding outside of any parentheses or exponent or whatever. So I know that this graph has moved up 4 units. If it was minus 4, I would know that it moved down 4 units. Looking at the second one, my parent graph is the absolute value of x. This time I have multiplied by a 4. I've got a 4 out front. That's not moving left, right, or up or down. What it's doing is shrinking or stretching the graph. And think about it this way, you're stretching vertically. So a number bigger than 1 stretches it, a number smaller than 1 shrinks it. So this would be a vertical stretch of 4. Basically what you've done is you've taken that graph and stretched it 4 times taller than it was previously. Looking at this last one, I've got a parent graph of 2 to the x power. And this time I have a -5, but notice it's in the exponent with the x. It's kind of the same as being in the parentheses or in the brackets. That means that I'm moving left and right. Now remember, it's the opposite. So because it's -5, I am moving to the right 5 units. Really pay attention to that because, again, it's kind of the opposite of what you think it should be. Right is minus and left is plus. Up is plus, down is minus, and then shrink or stretch is just a number, okay? So here we have described the transformation in words. If I go back looking at the graphs, we were writing a rule. So sometimes you're given the 2 equations and you have to describe the transformation. That means use words. Sometimes you're given the graph and you have to write the equation to describe the transformation of that. Again, I hope that this has made sense for you. I'm going to have a couple more videos talking a little bit more about this. Feel free to watch them to get more information. As always, if you have any questions, shoot me an email or catch me in class and we can chat more about this. Hope you have a fantastic day.